Hello, calculus scholars. So today we're going to go from just computing derivatives and coming up with those polynomial equations to actually using them so we can actually determine what the slope is at a point exactly. And we can also find the equation of an exact tangent line as well. So those are, sort of our usages. So substituting x values in the derivative that you found to find a slope at a particular x value, and then utilize the point slope formula from like Algebra 1 class, which if it's been a while, I'll write it down for you. So that's y minus y1 equals to m times x minus x1. Now, I know there's an obsession for like y equals mx plus b, but point slope formula is good enough, and it is an equation of a line, believe it or not. And you don't need to go through all the distribution and the pain of getting it into y equals mx plus b. All right, I like this example because it illustrates the many different interpretations of a derivative. So one type of wording that you may see is slope at a point. So what this means is I find y prime. Sorry, excuse me. So I'm going to find y prime. And I'm just going to have the general equation here. That's going to be 2x cubed minus 1. And then that plus 2, remember, derivative of constant is 0. And then I'm just going to plug in 2. So that's going to be 2 times 8 minus 1, which is 16 minus 1, or 15. No limit definition of derivative needed. Now, also, we could be saying write the equation of a line that is tangent to y equals to 1/2 x to the 4th minus x plus 2 at x equals 2. So this is our slope. Remember, we want to use the point slope form equation. So the y just stays as y. The m was 15. And I need to find my x1 and y1. Now my x coordinate is 2. And I could actually just plug in 2 to find a y value. Cancel out. 2 to the 4th is 16. We're at 8. So our coordinate is 2, 8. So now I can just put that in. So it's y minus 8 equals to 15 times x minus 2. Ta-da! It's the equation of a line. No need for y equals mx plus b. For those of you who are AP physics people, you may be thinking about like instantaneous rate of change. Velocity is your instantaneous rate of change of position, and your acceleration is your instantaneous rate of change of velocity. So what I would do for this is I would write down s prime of t first. So that's going to be 2 times negative 4.9. So that's going to be negative 9.8 t plus 40. And then I'm going to do s prime of 3. So that's going to be negative 9.8 times 3 plus 40. And we get, that should be negative 29.4 plus 40. We're just going to subtract that. And that's the instantaneous rate of change. So I like this kind of like side by side, so you can kind of see the applications of the derivatives. So finding just the slope at a point, finding the exact equation, so you can actually find the y value of the point, and the x value, and then you can find the slope. Actually, if you ever see this, you could just break it down. Well, the m just means find the slope, aka take the derivative, and then you do x1, y1, and this just means plug in x to find y. And then I like that instantaneous rate of change one, especially useful for your AP Physics people in here, or anybody interested for that matter. Okay, let's actually look at some delta math examples here. This one says, find the equation of a tangent line at a point where x equals to negative 4. So I got my x, that's my x1. May even want to, keep score on this. Yeah, let's actually keep score. So I need my m, my x1, and my y1. X1 is negative 4. Now, to find my y, I'm just going to do f of negative 4. That's going to be 2 times negative 4 squared plus 5. Negative 4 squared is 16. So this is going to be negative 32 plus 5 for a grand total of negative 27. So that's my y1. And then let's do our m. So our m is going to be f prime of x. We'll find that first. So we get negative 4 x. And we want f prime of negative 4. For a grand total of 16. And then I'm just going to do the y minus y1 equals to m times x minus x1. So our y is going to be a negative 27. Our m is going to be 16. And then our x1 is going to be negative 4. And we could clean this up a little bit, so we get y plus 27 equals to 16 times x plus 4. And we're done. All too often, people waste a significant amount of time, worrying about the algebra after getting it into the y equals to mx plus b, but you don't need to do that because you have the equation of a line when you do that. So I just had to compute my y value, just like I would have done like at the beginning of algebra 2. Simple derivative, plug in the x value into that. I kept score over here, and then I created that exact equation of the tangent line. All right, one more. I like this one because it says, given the function f of x, determine all the coordinate points on the graph for which the function has a slope of negative 4. So we want m to be negative 4. In other words, we want f prime of x to equal to -4. So let's actually compute f prime of x. So I'm going to get 3x squared plus 12x plus 5. Constant goes away. So you're at a -4 there. And then I'm just going to add 4 to both sides because you want those quadratics to always equal to 0 before you solve them. Remember, the rule of factoring, GCF is your BFF. So I'm going to pull out a 3. And then I'm going to just factor that. So I get x plus 3 times x plus 1 equals to 0. So I get x plus 3 equals to 0 and x plus 1 equals to 0, making our x have a slope of -4 when x is equal to -3 and x is equal to -1. Okay, so we found the x points. Now we need to find the y points. So we just are going to plug in our -3. And not something a little algebra 2 can't do here. So this could be -27. And then I got 6 times 9, which is 54. So let's see, I got -27 plus 54, so that's 27. Minus 15 is 12 plus 2. And by the way, y and f of x are used interchangeably. So we have a -3, comma, a 14. And likewise, we're going to do the x equals to -1. So I'm going to do -1 cubed plus 6 times -1 squared plus 5 times -1 plus 2. That's going to be -30. -1 cubed is just -1 plus 6 minus 5 plus 2. And let's see, 6 minus 5 is 1 minus 1. We're just left with 2. So we would have -1, comma 2. And those are the 2 points for where the slope is -4. So what you can do with derivatives, so you can use derivatives to find a slope at a point, and you can even find the exact tangent lines. And this is actually kind of nice here too, because it says, given the function, you'll find the coordinates of both points on the graph that has that slope of -4. Thank you very much for tuning in, and have a great day.